Hello guys, our today's topic is changes of state, and in changes of state we study sublimation, deposition and evaporation. In previous lecture we already studied about freezing, melting, boiling and condensation. We call of the states of matter. First it's solid. In solid the particle arrangement is tightly packed. In liquid the particles can roll upon each other or slide past each other. In gases, the particles have free spaces among them. Learning outcome, you'll be able to explain how a change of state occurs. You'll be able to compare and contrast the rest of three common changes of state, and you'll be able to cite a few applications of change of state. Change of state occurs when matter changes from one state to another. It is reversible. If you are converting solid to gas, then you can convert gas back to solid. So it is reversible. It is a physical change. There is no chemical bond involved, breaking of chemical bonds, or there is no formation of new products. It's just the change of state. Then it occurs when heat is removed or added. Either you supply heat or you take away heat. Supply heat means heating and taking away heat means cooling. Types of changes of state. First one we are going to do is evaporation. In evaporation, liquid changes into a gas when the heat is added. For example, wet clothes drying in the sun. In this image, you can see this pair of socks contains water. It will never reach its boiling point of water, but the water in it will disappear and the pair of socks will dry up. This all happened because of the process called evaporation. Evaporation is the process where liquid turns into gas at any temperature below its boiling point. It happens when high energy particles at the surface of the liquid gain enough energy to overcome the forces of attraction and escape into the air as a gas. Evaporation, it occurs only at the surface. Only particles at the surface gain enough energy to escape. Happens at all the temperatures. Unlike boiling, which happens only at a fixed temperature, evaporation can occur at any temperature or can occur at lower temperatures, that is below boiling point. Evaporation will be faster when the temperature is high because the particles will have more energy to escape. Similarly, evaporation will be faster when it has larger surface area because more particles are exposed to air. When lower humidity is there, like when the humidity is lower, dry air allows more particle to escape. More air movement can lead to faster evaporation as moving air carries away evaporated particles, speeding up the process. Thing to be noted in here is different substances will evaporate at different levels. For example, if we take off ethanol, which is commonly used in sanitizers or in hand gels, that will evaporate faster than water. There's a question for you now. The boiling point of water is 100 degrees Celsius. When does the evaporation of water takes place? When the temperature is less than 0 degrees Celsius? When the temperature has reached 100 degrees Celsius? When the temperature is less than 100 degrees Celsius? Pause the video, think, and then check your answer. If you answered the temperature is less than 100 degrees Celsius, you are correct because evaporation does not need a boiling point. It can happen at temperature less than or lower than boiling point. The next change of state is sublimation. Sublimation is when a solid directly changes into gas. Mind it, solid, the particles are very tightly packed. In liquid, the particles are have very little space, whereas in gases, the particles are further away from each other. In sublimation, solid directly convert into gas. There is no liquid state in between. It happens when the heat is added. Example, dry ice. It is a solid form of carbon dioxide. You must have seen dry ice to welcome people like in weddings or in some social events. It is used to create effects. Sublimation is the process where a solid directly changes into a gas without becoming a liquid. There is no role of liquid in here. It directly changes from solid to gas. This happens when the particle in the solid gain enough energy to break free from their fixed position and move apart like gases, from tight arrangement to very easy movement of particles. Key points. Solid changes directly into a gas. This is a solid. Just see how tightly packed the particles are. And this is gas state, and look how much spaces it has between particles. This skips the liquid state. The substance goes straight from solid to gas. It requires heat energy. The particle absorb enough energy to overcome strong forces of attraction. Occurs in substance with weak intermolecular forces. Some solids have forces weak enough to allow direct conversion into gas. There's a question for you. Which of the following substances undergo sublimation? Clothes drying in the sun, mothballs shrinking over time, ice kept outside refrigerator, or water in the puddles disappearing after some time. Pause the video, think of an answer, and then check whether you're correct or wrong. If you answered mothballs shrinking over time, you're correct. Clothes drying in the sun is evaporation. Then mothballs are solid. They are shrinking, that is, they are disappearing into air, so it is sublimation. Then ice kept outside the refrigerator. Ice is solid, converting into liquid. It is melting. And water in the puddle disappearing after some times. Water is liquid, liquid disappearing into gas. What it is? Evaporation. Because it is not boiling, it is not forming bubbles, it is just disappearing after some time. Third change of state for today's lecture is deposition. In here, gas changes into a solid when the heat is removed. For example, formation of frost. Deposition is the process where a gas changes directly into a solid without passing through the liquid state. This happens when the gas particles lose energy quickly, causing them to bond together in a fixed solid structure. In here you can see gas, and in here it is solid. Because it has lots of space between them, that is why it is gas. It is tightly packed, hence it is solid. So when gas changes directly to solid, it is deposition. It skips the liquid state. The substance goes straight from gas to solid. Occurs when the gas particle lose energy rapidly, typically due to cooling. Opposite of sublimation. Instead of solid to gas, deposition is gas to solid. So if it is going from solid to gas, it is sublimation, and if it is going from gas to solid, it is deposition. Question time for you. What must happen for deposition to occur? Particles must gain energy, particles must lose energy, particles must spread out, particles must break bonds. Pause the video, think of an answer, and then check whether you are right or wrong. If you answered particles must lose energy, you are correct because it happens when you take or remove energy. Are these two the same? Which two? Evaporation and boiling. First, we look at the similarities. They both involve liquid turning into a gas. They both require heat energy. Both involve particles gaining energy and moving apart. Both depend on temperature and surrounding conditions. So these were the similarities between evaporation and boiling. Now, how will you differentiate whether it is boiling or evaporation? Let's see. Differences. When does it occur? Evaporation occurs only at the surface, whereas boiling occurs throughout the liquid. Evaporation is a slow process, whereas boiling is a fast process. Temperature. Evaporation can occur at any temperature below boiling point, whereas boiling occurs at a fixed temperature. Bubble formation. There are no bubbles formed, whereas in boiling, bubbles form as gas escapes. Energy source. Evaporation can occur naturally, example with sunlight, whereas boiling requires continuous heating. For this, the examples are how puddles dry up after some times, whereas boiling is how liquid changes to gas when you boil water in a pan or in a kettle. What's that state again? Change of state occurs when matter changes from one state to another. In today's lecture, we studied about evaporation, sublimation, and deposition. One thing I want you to remember is that we know there are three states of matter, and when these three states of matter, when the energy changes, out of these three, gases has the highest energy, has the highest energy. So if we have to convert anything to gas, we have to provide it the highest energy of all. You can check out YouTube Shorts or Instagram handle or TikTok for related practice questions. Thank you.